Let's take a look at question number 6 from your 2014. Number 6 means that it was non-calculator, so just be aware of that moving forward. I'm given a differential equation. What does that mean? It means, hey, I'm given a derivative, and then they're going to ask us to work with that. Now, typically, slope fields can be involved in this, but the way that they ask this question is not necessarily really normal. It asks us to sketch the solution curve. That's not something that we're asked to do a lot, but we did go over that in class a little bit. It's got to be going through the point 0,1. So I'm going to make sure that I put that on the graph here. Okay, so I've got the point 0,1. That's where it's located. And then I'm looking for a channel. Remember, this is not connect the dots. I'm looking for a channel that I can fall through so I can create a little bit of this curvature. Now, I don't know exactly what this looks like. It does look like somewhere in here I'm flattening it out so that I can turn. I don't have exactly horizontal slopes, but pretty close. Okay, some sort of channel. Now, it's really tempting to just automatically assume that there's some sort of symmetry and kind of make the same thing on the other side. Don't do that. Okay, let's see if we can find the channel, because you'll notice that this gets pretty steep. So if I'm going to go in this channel, that channel actually goes a little steeper than it probably should. So again, I'm just trying to find a little bit of a path. It doesn't have to be exact, but it is important that you didn't just create symmetry and that you went through the point 0,1. Okay, that's really what we're looking for, but that's what that graph should look like. Again, not asked to do often to sketch the solution curve. It's much more feasible for them to ask you to actually draw the slope field in a few different points than this, but it is something that you've been asked to do in the past. All right, now B and C are pretty normal. One of them is write the equation of the tangent line at a point and then approximate. Then the other one is find the particular solution to the differential equation. You've been asked to do that quite a bit over the course of the year. The first thing you've been asked to do is find the equation for a tangent line. We've been doing that since September. Equation for the tangent line requires 2 points. Two pieces of information. A slope and a point. You need 2 pieces of information. That's all you need. Because you're in calculus, we need the slope at the point given, right? So it's asking us to draw the equation for the tangent line at 0,1. So I'm looking for the slope. Well, I was given the derivative, so now I'm just going to plug in a 1 everywhere there's a y, and I'm going to plug in a 0 everywhere there's an x. So that looks like 2. What's cosine of 0? That's just 1. Be careful with that. So my slope is going to be 2. Now, I already have a point, so I don't have to work for my y value. It's going to be y minus y1 equals 2 times x minus 0. Now, that is sufficient. You do not have to do anything else other than that. If you would like, you can simplify it. I would not suggest it, because if you simplify it and make an error, you'll be wrong. But if you want to write it like this, that's okay. If you want to write it like this, that's okay. All of those are legitimate answers, but if you make an error, for some reason you make that subtraction, now all of a sudden you don't get the point for the answer. So I would prefer that you just leave it in this point slope form. Okay, I think that's legit. The next step in this was reuse that equation to approximate f of 0.2. So I'm going to use this equation right here, because that's what I would want you to do. I'm going to use that, but I am going to have to move the 1 over. So what this is saying is we are approximating what's happening at 0.2, so really close to 0, using the tangent line. So f of 0.2 is approximately, right? And then I'm going to move that 1 over, just like we did over here. And I'm going to say 2 times x minus 0. Right? Oh, not 0. Sorry. I got to put in the right spot. So, that is 0. Sorry, I'm thinking about the 0.2. So, plus 1. And then right there, okay, I'm going to plug in a 0.2 for that value. So, f of 0.2 is approximately 2 times 0.2 plus 1. Well, 2 times 0.2 is 0.4. So, f of 0.2 is about 1.4. Okay, again, the approximation sign matters because you're communicating to your reader or to your grader that you know that this is not an exact value for the function. If you want an exact value for the function, you're going to have to find what the original f of x was. And that's what part C is asking you to do. It's saying find f of x. Find the particular solution, which means there's no plus c involved. Find the particular solution with the initial condition 0, 1. So we always start with a separation of variables, right? We're going to have to get all my x's on one side and all my y's on another. Now, some of you are going to be tempted to distribute, but that's not going to help you. Remember, we're going to have to divide and multiply to get things back and forth. Just adding isn't going to get it done. So I'm going to divide by 3 minus y, and then I'm going to multiply this side by dx. So I get dy over 3 minus y is equal to cosine of x dx. Now, once you've separated the variables, now you're eligible for all the remainder of the points. If you don't separate the variables correctly, you can't get any of the other points. And now I can integrate, though. So you should know the integral of cosine. However, you may get stuck on this. This requires that the bottom is now raised to a 1 power. And if the denominator is raised to the 1 power, you are going to be looking at a natural log. Please be careful. If u is going to be 3 minus y, your du is not just dy. Your du is a negative dy. So what that means is that you're going to have to deal with an extra negative in the process of this integration. So we would say that we're basically integrating a negative du over u, right? And then, of course, the integral of cosine is just sine. And you got to put that plus c on there. Now, I haven't integrated the other side, so I'm going to go back to that. But I wanted to go ahead and integrate the cosine. So let me jump in here. Here we go. I've got negative natural log of u, and u is 3 minus y, equals sine of x plus c. Now, we are going to have to solve for that c value, but I'm not going to do that yet. I'm going to go ahead and get rid of the negative sign. Remember, to get rid of the natural log, you're going to have to use an e. But you can't use that e. I don't know why my iPad did that. You can't use that e until you get rid of that negative sign. So you cannot exponentiate until you get rid of the negative. So let's do natural log of 3 minus y is equal to a negative sine of x. And then plus c minus c doesn't really matter, right? Plus 2 minus 2, I'm going to be able to solve for that c later on down the line. Now let's exponentiate. So e to that and e to that. Now, because these are right next to each other, they will reduce. Now, I still have a negative over here, but remember, I wasn't trying to reduce over there. I'm trying to reduce e with ln. Now I can do that. I've got 3 minus y is equal to, remember, I'm going to go through this step with you. You don't have to do this. But you're creating a situation where you are multiplying e to the negative sine x times e to the c, and that's why this became just a constant. So we want to write it as 3 minus y equals c e to the negative sine of x. Now that is a negative exponent right now, but I'm going to worry about trying to figure out what c is before I go into my process of trying to eliminate the negative exponent, all right? Now, if you want to do it right now, you can. If you want to move the y stuff over, you can. It's totally up to you. I'm going to go ahead and plug in right here. So I've got 3 minus, and I'm using that point. So my y value is 1. 3 minus 1 is equal to c e to the negative sine of 0. I'm just plugging in a 0 where x is and a 1 where y is. So 2, now that's e to the 0 is what that is, because sine of 0 is 0. So e to the 0 is 1. So that means the c must be 2, right? So I can rewrite this as 3 minus y equals 2 e to the negative sine of x. And now I'm going to solve for y. So I want to go y is equal to, now what I do mentally is I add this y over here and I subtract this over there. It's totally up to you. But it would be 3 minus 2. And if you wanted to get rid of the negative exponent, you would just move that down into the denominator. That is your particular solution for this differential equation. The negative piece is pretty significant over here. If you can't get that, you're going to struggle through the rest of it. But that is the process.